Hello, Professor. We are Group 2, and today we'll be presenting our weekly development progress report for CSA Sports Performance Building Blocks. Next. Here is a quick overview of our team. Next. This is the table of content. Next. Project overview. The CSA Sports Performance Dashboard aims to support hockey athletes by tracking their progress in leadership, accountability, and other core traits. Next. Project progress overview. Next. Here is the process flow. Next, project strategies. Our strategy focused on understanding client needs through walkthroughs, mapping data features, and using standard pre-processing techniques. We tried multiple models and finalized visualizations and documentation based on both performance and clarity. Next, these are the tools we used. Next, here's a snapshot of our weekly development. Next, data collection and analysis. We cleaned and structured the raw data set from CSA. Using Python, we handled missing values and created a cleaned version for modeling. This was later exported to Excel to support structured visuals and comparison across all the sessions. Here are some visualizations from Python. We used Python to generate general detailed visual insights across 5 sessions. This helped identify improvement trends and gaps in athlete performance. So here is the code for the data overview. We are importing necessary libraries, loading the data set, and then we print basic information such as shape of the data set, column names and data types, first 5 rows for preview, summary statistics of the data. Next, we are handling missing values and duplicates. After that, we are performing data cleaning and improvement calculation, stripping spaces from column name, calculating improvement by subtracting pre-values from post values, computes the average for all pre, post, and improvement columns. EDA provides solid foundation for identifying trends, evaluating sessions effectiveness, and making data-driven insights. Moving on to visualizations. Here we are performing session performance comparison for pre-values versus post to identify sessions where athletes improved or where additional focus may be required. So basically this chart shows average improvement scores for each metric in session 1. For example, there is a 57.89 percentile improvement. Next are the visuals representations for other sessions. Each session is assigned a unique color for pre and post data and corresponding improvement columns. Color coding allows for easy identification of high performing and low performing sessions. Visually analyzing patterns across sessions makes it easier to detect sessions with highest or lowest improvements and consistency in performance across different sessions. We are also visualizing average session performance to identify overall trends across sessions, which is useful for understanding the effectiveness of the training program as a whole. Finally, we can also identify outliers or consistent performers from these visuals. Thank you. Over to my colleague Darshana.
Hi everyone, I will introduce you to the machine learning models that we have implemented in this data set. This slide demonstrates how we pre-process our dataset for machine learning models. We start by selecting relevant features and keeping only numerical columns. The dataset is then split into training and test sets, ensuring a balanced distribution using the stratification. Since some models like logistic regression, k-nearest neighbors, and support vector machine require standardized input, we have applied feature scaling in order to normalize the data. Next slide. This slide represents decision tree models for predicting S1 performance and S5 communication abilities. The model highlights key factors like ethical leadership, athlete identity, and leadership capability. The graph shows strong alignment between actual and predicted values, demonstrating high accuracy and minimal prediction error. The decision tree diagram illustrates how different attributes influences the outcome. Overall, our models provide clear insights into performance prediction, making them effective tools for the analysis. Next slide. We have predicted 5 different models, namely Bernoulli naive Bayes, random forest, linear regression, k-nearest neighbors, and support vector machine. The target variable for 5 models were S1 success rate post. Now let's move on to the Jupyter Notebook Live in order to further look into the models. First, I will start by explaining the Bernoulli naive Bayes. which is designed for binary features. The model is known for its simplicity and fast execution. However, in this case, it has achieved only an accuracy of just 0.25, as you can see, indicating limited predictive power. Looking at the classification report and confusion metrics, we can see imbalances in precision and recall, meaning the model struggled to generalize well. These results suggest that feature refinement or trying a different model might be necessary in order to improve the classification performance. A better approach could involve in engineering more informative features or using a model that can better capture the relationships in the data. Next we can look into the random forest model. For this model, we have used an ensemble of 100 decision trees. Random forests are known for its robustness and resistance to overfitting. However, in this case, model performed poorly and achieving an accuracy for only 0.25. Looking at the classification report, we see low precision recall scores indicating the model struggled to distinguish between classes. Confusion metrics also highlight misclassification. This suggests that the dataset might have limitations such as small sample size or class imbalance, preventing the model from capturing meaningful patterns. The strategies like feature engineering, data imbalancing techniques, or trying different models improved our performance. Over to Harsha to look into the further models. Thank you.
Thank you, Darshana. The other three models are logistic regression, KNN, and SVM. We will go to Jupyter Notebook and I'll walk us through that. Logistic regression is a statistical model used for multi-class classification, predicting the probability of a categorical dependent variable based on one or more independent variables. Here, the model has an accuracy of 75% with good precision for predicting class 9, but struggles with recall for class 9. The confusion metric shows the model correctly predicted two class 8 instances, but made one mistake on class 9. Next is K nearest neighbors, which is a classification algorithm that predicts the label of a data point based on the majority label of its nearest neighbors in the feature space. Here, the model has an accuracy of 50% with perfect recall for class 8, but fails to predict class 9 at all with 0% recall. The confusion matrix shows the model correctly predicted both class 8 instances but made mistakes on all class 9 instances. The next model is support vector machine, which is a supervised machine learning algorithm. Next, Mehak. This SVM model is a supervised machine learning algorithm used for classification, which finds the hyperplane that best separates different classes in the feature space. Here, the SVM model has an accuracy of 75%, performing well in predicting class 8 100% recall, but struggling with class 9 50% recall. The confusion matrix shows it correctly predicted both instances of class 8, but misclassified one class 9 instance. Next, we compared all the 5 models here, and the performance of all the models is quite low, with all showing zero precision recall and F1 score, except for logistic regression and SVM, which both have an accuracy of 75%. Despite this, none of the models show good classification ability, but logistic regression and support vector machine are the best based on accuracy so far. And this is the visual representation of the classification, and these are all the confusion matrix of the all 5 models. Next, over to Mehak. Thank you.
Thank you, Harsha. So I'll be explaining the feature selection for all the 5 models separately. So here are the snapshots from our Python notebook. So this is the summary for all our 5 sessions, and this is the conclusion based on our models separately, and this is the overall conclusion. So let's go to the Jupyter notebook quickly. So this is feature importance for Bernoulli naive Bayes. So the top 10 features for the naive Bayes. So S3 accountability commitments improvement is leading in that. Next we have for the random forest. In random forest, the same S3 accountability commitment improvement, which is the leading factor, a variable in our top 10. And then for the logistic regression, we have S3 accountability words and action improvement, which is the leading factor in the logistic regression. Here it shows a linearity. And for these are the top 10 feature importance for the k nearest neighbors. And then we have for support vector machine. In the support vector machine, again S3 accountability words and action improvement is the leading factor. Then we have a quick summary for all the models, feature important summary for all the 5 models here. Then let's go to the conclusion based on the feature importance. So what we got from the random forest is random forest capture non-linear relationship and is sensitive to feature interactions, and logistic regression assumes linearity between features and targeted variables, where while k nearest neighbors like kn is sensitive to irrelevant features. So retaining the most important features is crucial for model performance. Support vector machine benefits from the ability to handle higher dimensional spaces and is effective at identifying the most significant features in such contexts. Bernoulli naive Bayes assumes independence between features and does not capture feature interaction as well as the other models. Uh, in overall conclusion, we got random forest seems to provide the most comprehensive feature importance analysis, as it can handle complex relationship interactions, while logistic regression and SVM highlight features that contribute linearity to the prediction. KNN is heavily dependent on feature selection, while naive Bayes provides insight into feature importance. So in general, using multiple models and comparing their feature importance allows us for a more robust understanding of the dataset and key factors driving predictions. Thank you. Over to Arjun.
Thank you, Mehak. Yeah, let's start from the Jupyter notebook. I'll tell you about the predictive improvement. So as you can see in this code, we have created charts, which tells us the bar charts, which displays the top 10 sessions with the highest and the lowest improvements. If you go down, yeah, those are the bottom 10 sessions with low predictive improvements. And then we have the pie chart, which shows, and then we have the pie chart, which shows the 66.3% of session having high improvement, while the remaining 33.7% having the low improvements. So these insights help identify area that need targeted interventions to enhance performance. Over to the slide. Yeah. So let's talk about the predictive modeling and machine learning. So it explains the challenges faced with initial models like logistic regression, knife bias, and random forest due to class imbalance, which affected class 1 prediction accuracy. Although logistic regression achieved 75% accuracy, it struggled with class 1 performance. To improve predictions, KNN and SVM models were introduced in week 8 for better analysis of feature importance. Next slide, please. So over to the yeah, to the Jupyter notebook, the cost one. Yeah, as you can see over here, the cost is breakdown into several parts. So the total theoretical cost. So as you can see, the breaking of the theoretical cost into two, the project mobilization phase are around $50 and the project initiation phase around $600. And then the current spend is divided into four phases. As you can see, the required phase is $350, design phase is $1350, and the model valuation phase took around $450, and the dashboard development phase took around $150. To the down. Yeah. Yep, over here. So in this, if you see, the total theoretical cost is $650 and the current spend is 20. Yeah, to the down, Mehak, little bit more down. Yeah. The dashboard development phase is $650 and the testing and iteration phase took around $600 and the remaining report preparation phase took around $500. Over to the slide, Mehak. Yeah. So now let's talk about the key milestone achievements. So it's successfully completion of major tasks, including data processing, exploratory data analysis, implementing machine learning models, and finding Power BI and visualization. So the midterm presentation with client approved visual elements was also delivered. Challenges encountered including data update delays, tool selection confusions, low model accuracy due to class imbalance, and limited visual engagements. Next slide, please. So next is the test dashboard, which represents an integrated sports performance dashboard designed to identify individual strength, track growth, trends, and highlight area needing supports. So the dashboard shows a 23.64% average improvement in confidence, reflecting the positive impact of targeting coaching. Next slide, please. So next is the dashboard development summary. These are the three steps which we used, and the result is a set of dashboard that effectively track trends, highlight top performers, and pinpoint area needing attention. Next slide, Mehak. Yeah, this is the slide where we have the communication with the client, which highlights the positive engagement with the client throughout the project. It shows the ongoing communication with emails where feedbacks and projects documents are shared and discussed. Next slide, Mahek. So this is the client feedback, and here we have the positive feedback from the client, particularly appreciating the visualization and dashboard layouts. So the midterm presentation was well received, and the final dashboard is in progress. The next step is to include finalizing the dashboard with added interactivity, submitting model documentation, and preparing for the final presentation. So in conclusion, it indicates that the strong improvement were shown in the athlete matrices, and the project goals were met successfully, and the project is ready for the final submission. Thank you.